Alright class, today we're in our second section of our 8th unit. We are studying cofunction and even and odd identities. We're going to be able to use cofunction identities to solve problems, use even and odd identities to solve problems, and use cofunction and even and odd identities in proofs. These are all the cofunction identities, and it can seem overwhelming, but for the most part, they're all kind of saying the same thing. They come from the graphs. So if we take, for example, a sine graph, this would be our parent function of our sine graph. And we take the cosine graph and plot it in the same plane. We discussed in our graphing unit how these two functions are only one phase shift or 90 degrees apart. So if I take this cosine graph and I move it forward 90 degrees, I would end up with the sine graph. And the opposite is also true. If I take this sine graph and I move it backwards 90 degrees, then I'm going to end up with the cosine graph. That's where these functions come from. So these are all saying the sine function is the same as 90, or pi over 2, minus x. The cosine is the same as saying the sine of pi over 2 minus x. Tangent and cotangent have the similar properties. The tangent is the cotangent of pi over 2 minus x, and the cotangent is pi over 2 minus x as well. And secant and cosecant follow those same properties. Make sure these are in your notes because we will reference them in the future. Using a cofunction identity, rewrite the statement in terms of cosine. So I start off with the sine of 30. So if I look here, I have a sine function, so it's using our first cofunction identity. I know that the sine of the angle is the same as saying the cosine of the angle of 90 minus that angle. So first, I'm going to apply this to a degree situation. Since I have 30 degrees, I'm going to think of this a different way. Because again, 90 and pi over 2 are the same measure, just at different units. So basically, I can say the sine of 60, or the sine of 30, is the same thing as the cosine of 90 minus 30, which we know is the cosine of 60. And I can verify that because 30 is a special angle. The sine of 30 is 1/2. The cosine of 60 is also 1/2. So we know that to be true. You can also apply the cofunction identities in a simplifying situation. The sine of pi over 2 minus x times the cosecant. Well, I know that cosecant is 1 over sine of x. Whenever I'm dealing with identities, I want the variable, or the angle, to always be the same. So pi over 2 minus x is not the same as x. So I want to get rid of that pi over 2 minus x. If we go back to our cofunction identities and we look, the sine of pi over 2 minus x is cosine. So I will replace that whole function with just a cosine. And now I can simplify from here. This part isn't new. Combine the fractions together since I'm multiplying. Cosine of x over sine of x, which is cotangent of x. These are the even and odd identities. And the even and odd identities, again, come from the graphing. And they come from changing the value of the angle. So, for example, if I have a sine function, and I take that sine function and I negate the angle, meaning that every angle that I put into it, I want to make it negative. What that essentially does to the graph is it flips the direction of the graph. It flips it over the y-axis. So we end up kind of looking backwards, like so. And if I continue it in the positive direction, if we note, this function and this function have kind of flipped. So it's the same thing as negating the whole function. The cosine one is actually kind of interesting, because if you notice, the cosine of negative t is just the cosine of t. And again, that comes from the graph. So if I plot a graph really quick, if I take this function and I flip it over the y-axis, which is what negating the angle would do, my function ends up looking exactly the same. Nothing changes. Compare 0 to 2 pi and 0 to 2 pi in both functions, they're exactly the same. So, cosine of negative t is still just t. And these variables could be anything. They could be x's, they could be thetas. It doesn't matter. Just like before, cosecant and secant have the same properties as sine and cosine. And then the tangent and the cotangent also end up just negating the whole function. We'll work with these more in class, but I wanted to give you a bit of an introduction of them beforehand. Let's apply it. I want to verify that this statement is true, meaning that I want to do a proof, which means that I can't move anything on either side of the equation. This time my angles are represented by theta. And again, negative theta and a theta are not the same thing, so I can't try to combine the cotangent of negative theta and the cosecant of theta. I want them to be the exact same unit. So the first thing I'm going to do, or my first goal, is to get rid of the negative theta. Following my cotangent rule, I'm going to look here. Cotangent of negative t is the same as saying the negative cotangent of t. So I'm going to replace the top of this fraction by the cotangent of theta, and then I have the cosecant on the bottom here. And then from here on out, it's just a normal proof. When you convert the cotangent to a negative, typically I put the negative sign on the top of the fraction. So I have negative cosine over sine over 1 over sine. Whenever I have a fraction over a fraction, I multiply by the reciprocal of the bottom fraction. So I have the negative cosine of theta over sine of theta. Flip 1 over sine of theta to give you sine of theta over 1. And I'm left with the negative cosine of theta, which is where I was going to in the first place. We'll cover this more in class. Again, this is just an introduction to these properties.